Hey, what's up, class? We are back for another little mini lesson on Back to the Basics, Math Basics Review. These are some concepts, once again, that you have learned in the past, but you're probably a little rusty on. So I wanted to review these, and here we go. So let me share my screen. This is Math Basics Review Part 2. You have these notes uploaded to Schoology, and here we go. So in this review, we are going to review the concepts of absolute value, opposites, reciprocals, and properties of zero. And these are all fairly easy, but like I said, you might be a little rusty. So here we go. All right, let's start off with absolute value. Okay, so absolute value is the distance a point is from another point. So the best way to give you an example here is I'm going to, on your notes, you have a little map of part of Norwalk. And here is the 5 freeway right here. And right here is the Circle K. Here is the golf course, and John Glenn's right there. And this is Shoemaker right here. So let's say you walk down here to this bus stop right here, and you want to go visit your friend in Bellflower. And Bellflower is way over here past the 605 freeway. So let's say you're going to go visit your friend, and so you take the bus. And so let's say it's 3 miles to Bellflower. So you hang out with your friend, and you spend the day there, and it's time to come home. So you get back in the bus, and you are going to travel another 3 miles. Now, at any point, did you travel -3 miles? If someone said, hey, how far is it to your friend's house? Do you say, oh, it was -3 miles? No, we don't talk that way. In distance is always positive. Okay, so if you were to take the bus to visit your friend in Bellflower, it's 3 miles both ways because we're talking about distance from one point to another. It doesn't matter if you started at the bus stop in Norwalk and got off at the bus stop in Bellflower, or if you started in Bellflower and went back to Norwalk, it's still 3 miles. We never say, oh, it was -3 miles. And this is the concept of absolute value. It's always positive. Distance is always absolute value, and it's always positive. Okay, so now what does that look like in a math problem? Okay, so that's the concept on a map, but in a math problem, this is what it'll look like. So I know that my little video picture here is kind of blocking some of this for you. So we'll do the best we can there. Okay, so absolute value. So if you were to say the absolute value of 3, the way we write that mathematically is we write it with these goalposts. Remember those goalposts look like this? So whenever you see this, the way you would read this is you would say the absolute value of 3. Okay, now I have a fun little strategy to help you remember because some of these problems can get a little tricky. We're going to do some practice problems here in a minute, and some of them are a little tricky. So the way that I teach my students to remember is I say, think about the church of absolute value. Okay, now what the heck what are you talking about, Mr. Mason? The church of absolute value. Okay, so I want you to think of church, right? Most of you have probably been to church at least at some point in your life. And normally when someone goes to church, regardless of the mood they're in, normally when they come out of church, they're feeling pretty good, right? You go and you sing some songs and you hear a good sermon from the priest or the pastor, and normally you come out feeling pretty good. Maybe if you go to the church for a funeral, you might not be feeling too good, but for the most part, when you go to church, you come out feeling pretty good. Okay, so I call it the church of absolute value. Now, I'm not talking about real church. This is a church of absolute value. So you always come out feeling positive when you go to the church of absolute value. Okay, so watch how I do this, and just bear with me. Some of you might think, oh, these strategies are lame and corny, but you know what? I've been teaching 25 years, and I'm a pretty darn good math teacher. So I would encourage you just to try these strategies. Okay, so here's the absolute value of -4. Okay, so -4 went in, let's draw our little church, went into the church of absolute value. So you have to remember this phrase. You always come out feeling positive. Say it with me. you always come out feeling positive. So he went in feeling negative, right? He was down, discouraged, a little depressed, didn't really want to go. His parents dragged him there. But you go in negative, you always come out. So you went in negative, you always come out feeling positive. Okay? So when you go into the church of absolute value, you always come out feeling positive. Now remember that, because in just a minute, some of you are going to goof that rule up. You always come out feeling positive. Okay? All right, so here we go. This guy, he went into the church of absolute value. He was positive. He's positive inside. So what is he going to be when he comes out? He's going to be positive or negative. Well, what did we just say? What was the rule? You always come out feeling positive. Okay? So if you go in positive, you still come out positive. You always come out feeling positive. Okay? All right, now on this next one here, we have a negative on the outside. So pay attention to that. The 3 went inside the church of absolute value, positive, right? So that's a positive 3 inside. This negative didn't want to go inside church. He didn't want to go inside, so he stayed outside. So this guy is going to come out feeling positive. So, oops, I forgot my little circle over there. So he's going to come out feeling positive. All right, so it's a positive 3, but then this negative is going to come over, and then he's going to turn him back into a negative. All right, he came over and he turned him into a negative. So that answer is actually -3, because the negative did not go inside. The 3 came out feeling positive, but then this negative went over and brought him back down. Got him all discouraged. Okay, all right, let's try a couple more here. All right, so this one's a little trickier here. Okay, so we have a variable inside. So we don't know what that number is, right? The variable could represent anything. But what we do know is that it came out positive. Came out positive. So we got to figure out, well, what could have gone in? So think about it for a minute. What could go in and come out being positive 10? Well, we know we could have put a positive 10 in. What else could we have put in? That's right, you could put in a negative. So it could have been a positive 10, or it could have been a negative 10. Could be either one, right? We don't know. So this variable could have been positive 10, or it could have been negative 10. If it was negative, it's going to come out positive. And if it was positive, it's going to still come out positive. Okay, all right, here we go. One more. This next one's a little tricky. Okay, so again, we have a variable, so we don't know. We don't know what went in, but we know that it came out negative. Okay, think about that for a second. We don't know what went in, but it came out negative. Now, what's the problem here? What's the rule? What did I already tell you? You always come out of the church of absolute value. You always come out positive. Did he come out positive? No, he didn't. He came out negative. Now, in math have rules that you have to follow. They're like the rules of the universe. And one of the rules is absolute value always comes out positive. So if this is not following the rule, then we have a special word for that. And that is no solution. There is no solution. You can't break the rules. So there's nothing that X could be. X could be, there's nothing. There's no solution that we could put here that would make this come out negative. There's no negative sign out here. If there was a negative, like up here, then we could say, oh, well, there's a negative over there. But there's not. So X has no solution. All right, no solution. All right, so think positive. Remember that. You always come out of the church of absolute value feeling positive. Okay, let's gonna move on to another concept here. So the next concept is opposites. Now opposites is pretty easy. Opposites attract, right? So opposites are numbers that are equal distance from 0. So from 0, so if you think of a number line from 0, equal distance from 0, and they just go in opposite directions, and they have opposite signs. So for example, if I said, what is the opposite of -3? Well, from here, if I go 1, 2, 3, what's the opposite of that? Well, that would be 1, 2, 3. So it's really the same number. It's just the opposite sign. So it'd be positive 3, right? If I went to negative 3, the opposite direction would be positive 3. Okay, so here's another one. What's the opposite of 1/2? Well, if I went 1/2, the opposite would be negative 1/2. Right? It'd be negative 1/2. If I go 1/2 to the positive, then it's still the same number, right? It's 1/2. I just changed the sign. Positive, the opposite is negative. Negative, the opposite is positive. Okay, so opposites. It's really the same number, just opposite signs, right? Opposites, positive and negative, opposites. Okay, now that is not the same as reciprocals. So here's part 3, reciprocals. Okay, so that was opposites right there. Those are opposites, same number, opposite sign, you change the sign. In reciprocals, you do not change the sign. If it's positive, it stays positive. If it's negative, it stays negative. Reciprocals, this is when you take a number or a variable and you flip it. So you flip it so that the numerator and the denominator changes places. So for example, if I take the fraction 3/4 and I flip it, right, it does a backflip, it becomes 4/3. This is its reciprocal. 4/3 is a reciprocal of 3/4. If this is positive, this stays positive also. You don't change the sign. Okay, opposites, you change the sign. Reciprocals, you're just flipping. Now, you can also do this with variables. So here's an example with variables. I have ax, a times x over y, and then the reciprocal, I'm going to flip these. It's going to do a backflip. The y goes upstairs, these guys go downstairs. So I have y over ax. Ax over y is a reciprocal of y over ax. Okay, and then one more rule about reciprocals. This is kind of a neat rule. When reciprocals are multiplied times each other, the product is always 1 over 1, which equals really 1, right? So if I take the fraction 1/3 and I multiply it times its reciprocal, I'm going to cross cancel. These 3's cancel, the 1's cancel, and I get 1 over 1. Okay, so reciprocals, when you multiply them, right, if I was to multiply 3 over 4 times 4/3, 4 and 4, those cancel each other, 3 and 3 cancel each other, or you could do 3 times 4 is 12, and 4 times 3 is 12. Okay, so the answer will always be 1 when you multiply reciprocals. Okay, so we have absolute value, we have opposites, we have reciprocals, and now we've got properties of 0 when dividing. The reason I'm going over this is a really simple concept, but students goof it up all the time. Okay, so there's 2 different properties for 0 when you're dividing, for division. Okay, the first rule is when you divide 0 and it's the first number. Okay, so when you're dividing and it's the first number, if you notice here it's 0 divided by 12, and over here is 0 divided by 3. So when it's the first number and you're multiplying by any other non-zero number, so this is 12 is not a 0, non-zero, 3 is not a 0, then your answer will always be 0. Okay, so let me go over that again. When the first number in the problem is 0, if the first number is 0 and you divide, then your answer is 0. Okay, 0 divided by 12 is 0. 0 divided by 3, if we write it like a fraction, it's still 0. That's when 0 is the first number. Okay, so some of you are thinking, oh, well, that's easy. It is. Okay, but now this is the next rule is where Math 1 students goof it up. Okay, now if you are dividing, but 0 is the second number, then the answer is going to change. It's not 0, and it's not 1, and it's not 8, and it's not -5. If you're dividing and 0 is the second number, here it's the second number, your answer is always undefined. That's the phrase we use. You can't divide by nothing. You can't divide by 0. Okay, so if 0 is the second number in the problem, 8 divided by 0 is the second number. -5 divided by 0, it's the second number. Then the answer is going to be undefined. It's not 8, it's not 1, and it's not 0. It's undefined. You cannot divide by nothing. Okay, here's -5 divided by 0. The answer is undefined. All right. Okay, so if it's the second number, it's undefined. If you're dividing and 0 is the first number, then your answer is always 0. We'll practice that, and it sounds like it's simple, but students goof it up, and that costs you a point on a test, right? If you're not paying attention and you don't remember the rules, that'll cost you, and that's the difference between an A and a B, or a B and a C, or a C and a D, okay? All right, so go ahead and write yourself a tip or a reminder. I don't think I gave you any practice problems on these. We'll do some practice problems in class. Okay, so go ahead and write yourself a tip or reminder. We did absolute value, we did opposites, we did reciprocals, and we did properties of 0 when you are dividing. Okay, let me go ahead and stop my screen. And hope you guys are doing well. Hope you're taking care of yourself. That lesson probably will take you about 15 minutes to do. Okay, we'll talk to you soon. We'll see you in class. Bye-bye.